Welcome to the final video for this series of casual math for grown-ups. And with this comes probably the most important topic ever because it precedes you in literally almost every single subject, and that is order of operations. The order of operations, if I were to give you multiple basic operations in the same expression or statement, there is an order to which you must solve those problems. Cool. There's an acronym out there. There's a different one from where, depending where you're at. PEMDAS. Please excuse my dear Aunt Sally, but I've always known it as just PEMDAS, right? That is P for parentheses, E for exponents, M for multiplication, D for division, A for addition, and S for subtraction. Essentially, if I were to give you a set of numbers with basic operations, that's the order typically that you would follow it in. There's some iffy ones out there too, we'll go over. But right, let's say, I'll throw one at you, it's just super easy. So essentially, right, I'm looking at this expression and I'm trying to find the number that this results in. 9 plus 1 is in parentheses, so I'm going to be doing that first. So this ends up being 10, and then I write out the rest of the equation again, times 3 minus 2. Next down the line, hey, I don't have any exponents in this one. We'll put an example next. But I have multiplication. That's next down the line. So I got to do that. That's 30. And then subtract 2, and my answer is 28. Okay, so the next example, I have 3 to the power of 3 times 2 divided by 2 plus 7. So I have this exponent. Obviously, that's the highest up the chain right now. That's this. I don't have any parentheses or anything. I don't have to worry about prioritizing parentheses. I do the exponent first. 3 to the third power is 27. And then I'm left with the rest of the expression, times 2 divided by 2 plus 7. 27 times 2, and then you also have division. Here's the thing about mainly multiplication, division, and addition, subtraction. These pairs here. If you see these in an expression and you're going from left to right, multiplication and division are essentially the same rank. Yes, it is after multiplication, but it's a bit of an exception. They are inverses of each other. They are reverse operations of each other. So technically, they are the same rank. We just have PEMDAS as a way of memorizing what we're looking for. So it's not exact. So in my case, I have on the higher tier multiplication and division. So what I'm going to do is I'm going to solve it from left to right. So 27 times 2 is 54. Now I'm left with 54 divided by 2 plus 7. I'm left with a division, so I have to do that before adding. Again, we're coming back to 27 and adding 7 to it, and we get 34 as our answer. Next example. A little more weird, right? I have in parentheses 2 squared plus 7 times 9, all of that in parentheses, plus 3 times 2. So coming back to PEMDAS, I gotta go through the parentheses first, but within that parentheses, there's a rank order. So we're gonna be bouncing back and forth here, right? I have an exponent within that parentheses, that's 4, plus 7 times 9. The parentheses is not resolved yet. There's still stuff I need to do. So 4 plus 7 times 9 in parentheses, plus 3 times 2. The 4 is fine the way it is because I'm not going to add yet. I have to now multiply this 7 times 9, which is 63, which is still in parentheses. It's still not resolved. Plus 3 times 2. Guess what? It's still in parentheses, so I still have to solve it. So this becomes 67. And essentially, I've already found this number in parentheses, 67. Oh, excuse me. 67 plus 3 times 2. Now that we're kind of out of the parentheses, now I have to prioritize 3 times 2 because that is being multiplied. So there's 6. 3 times 2 is 6. I just brought that down. 67 plus 6, therefore, is 73. And that's your answer. So it really depends what's being thrown at you. You have seen, right? Oh, okay. A negative base multiplied by, that, that this is going to be the quantity of itself multiplied twice. So this is positive. You've run into the situation of 5, let's say, to the negative first power, and that's equivalent to just a fraction of 1 over 5. And really, if you go to any power, 5 to the negative, let's say, negative 5th power, that's just 1 over 5 to the 5th power. And then whatever 5 to the 5th is, that's just your denominator. We've never asked the question, well, what about this? That, by the way, is a number raised to a fractional exponent. The answer is 5. Because guess what? 25 to the half power, to the power of 1/2, is the same as the square root of 25. Hey, bear with me now, bear with me. 27, another example, to the power of 1/3 is the same as the cubic root, or the 3 root of 27. The answer is 3.